Alright, so this is problem number 2 for the credit of exam 2, and it is number 23 from the exam 2. So to solve this equation, first we have to set up an ice table. Alright, so we've set up our ice table, and for the initial concentration of each, they tell us that for hydrogen and iodide, they are 2 moles each. So 2 moles. And then for hydrogen and iodide, we don't know, so we're going to put a 0 for the initial concentration. And then for the change in the molarity, we know that these are reactants, the hydrogen and the iodide, and the hydrogen iodide is our product. So as the equation goes down, the concentration of our reactants decreases, so minus x being an unknown, and then the concentration of our products increases, so plus x. Now, all we have to do is set up the equilibrium concentration equation for each. So the molarity minus the unknown, 2 minus x, and then for this is actually 2x, not plus 2x, not just x, because the 2 from the from right here, the stoichiometric 2 that they give us. What am I writing? Okay, 2x. So now we have to set up the equation for our equilibrium constant, and before anything, it tells that our equilibrium constant, so our Kc is equal to 54.3, and then we know that our Kc, our equilibrium constant, is equal to the concentration of the products over the concentration of the reactants. So now we have the concentration of our products over the concentration of our reactants, and remember that our hydrogen iodide over here has that 2 right here, so our hydrogen iodide is going to be squared. Now, our equilibrium constant 54.3 is equal to the concentration of our hydrogen iodide squared over the concentration of hydrogen iodide. Since we don't have any numbers yet for our concentrations, we add the equilibrium, and we only have for both hydrogen and iodide, we have the concentration, the initial concentration we don't have for equilibrium yet. So since we don't have numbers, we're just going to plug in the equilibrium concentration equations that we came up with over here. So we have done that. We plug in the 2x to the concentration of hydrogen iodide. Remember that it's squared, and then we plug in the 2 minus x to the concentration of hydrogen and the concentration of iodide. What happened there? Now I can't get rid of that. I'm sorry. Anyway, now what we're gonna do is, since we know that these two, another way of writing 2 minus x times 2 minus x is 2 minus x squared. Now, we're trying to get x by itself in order to solve for it. So in order to do that, we're going to square root both sides in order to get rid of these squares that we have on the other side. So the square root of 54.3 is approximately 7.37, which is equal to 2x over 2 minus x, since we've canceled out the squares. Now, in order to get rid of this part and have x on its own, we are going to multiply both sides by 2 minus x. So this side times 2 minus x, and then our 7 times 2 minus x. Right, so when we multiply 2 minus x to the 7.37, in order to simplify that, I guess, in a certain way, we're going to distribute the 7.37 to both the 2 and the x, and that's going to give us around 14.74 times or minus 7.37x, which is equal to 2x. Now we get rid of the 7.37x, so we add it to both sides in order to move our x's all to one side, and that gives us 14.74 is equal to about 9.37x. Now we just divide by our 9.37 from both sides and get our x is equal to about 1.57. So we have solved for our x, and we know that it is 1.57. However, we're not done yet, as we had come up with the equilibrium equations for the concentration of both our hydrogen iodide and our hydrogen iodide. All we have to do now is plug in our x into the 2x equation of equilibrium for the concentration of hydrogen iodide. So 2 times 1.57, it's going to be equal to our concentration of our hydrogen iodide, and that is about 3.14, equal to concentration hydrogen iodide. However, the closest thing we have to that is our 3.5, and that's still a far stretch, because if we round the 3.14, we get 3.1 molars. So our answer is going to be none of the above, because none of these are the answer. Thank you.